What's up, guys? Let's take a look at another CodeWars exercise. This one's called digital root, and the idea is you take a number and you add up the digits. So if we had 16, we'd add 1 to 6 and get 7. But if we still had multiple digits after that, we'd take the result and put it back through the same process as many times as we needed. So if we start with 942, we'd add 9, 4, and 2 and get 15. Then we'd add 1 and 5 and get 6. And we'd keep doing that as many times as it took. So this kind of thing can be achieved with a loop. Totally fine. We've used loops ever since the beginning. But there's another way to achieve it that I wanted to show today. And that is called a recursive function. A recursive function doesn't try to do the whole job all at once. It just does a little piece, and then it sends the result back through itself to do the next piece. You'll keep going until we hit what you call the base case, which is just like the end, the last thing that actually returns a number instead of calling itself again. So writing a recursive function can be really nice because you really only have to say two things. What do we do each time? When do we stop? And that's kind of like a loop, but it can be a little more clear when you arrange it this way. So let me show you. We have the end. Sometimes I do that last, sometimes I do it first. In this case, it's the easy part, so let's do it first. Where do we end? We end if it's a single digit. So I'm going to say if n is less than 10, we return end. That's when we finally got down to a single digit, we return it. Now less than 10 might not be perfect, because if we had a negative 25, then that would not be a single digit. But in this case, we're not going to have any negative numbers. Now, what we're going to do is one single step of this thing, not try to do it all at once, and then just put it through the function again until we finally got less than 10. So what that means is we're going to end up mentioning the function inside itself to call itself, which I don't think we've ever done before. And then we're going to put the new input, which is the sum of the digits. Now, this is the ugly part. This is the part that's not fun, because whenever we deal with digits, we might have to go from an int to a string and then to an int, and that adds a little bit of extra typing, a little bit of ugly stuff. Let's give it a shot. I'm going to go the sum of the int of the digit for the digit in the string of int. So if we take n and separate it into digits, and then we take each one and make sure it's an integer, add them up. Now we just return that. And that's it. Unless I missed some parentheses, we got it. So recursive functions almost feel like you never did the work at all. It feels like, oh, where did it happen? And it just happens a little bit each time it cycles through until it hits the end. This is not always clear. It's not always great. But every once in a while, you'll find a situation where a recursive function works wonderfully. Let's take a look at the solutions from other people and see what they did. This first one is pretty much the same as ours. It's one line because they have a ternary expression to handle the if, and they use map to do the int on each digit instead of using a comprehension or a generator expression to do the int on each digit. But it's the same process with the same logic. Maybe you like theirs because it's shorter. I certainly do. I kind of wish I had done that, but it's all right. Now the next one is even cooler because they solved it with math. They were able to realize that you can just prove the answer instead of getting there manually one step at a time. Now I haven't thought about it much. I haven't looked up the theory behind this, but apparently if you take n modulo 9, that'll usually give you the answer, or we can find another way to do it. Now, this person used the while loop, which is super similar. Like this chunk here is exactly the same as this chunk here, which is doing exactly the same as this chunk here. It just looks different. And their while loop was a way to do that thing again and again, just like our recursion was a way to do that thing again and again. So that loop looks good. This loop, not quite so good because it's very long and it's separate loops. This one, a bit longer. This one, even worse. And you can see why recursion has allure. You can see why it's interesting, because we don't have to do all these steps. We can just say, hey, do one layer, peel off one layer, and then send it back through the layer peeling machine until it hits the core. And we write 2 lines, we're done. It even explains itself, like you're naming the function inside of itself, so it tells you what it's doing, rather than when you look at this, you're like, what the heck is X and Y? Is this 2D coordinates? I don't know. And it can be nice. I'm not saying you should start using recursion for everything. That would be a bit of a paradigm shift. Some languages do. Some languages have no loops and they use recursion as their way to repeat things, but their whole setup is for that, and Python is not really built in such a way. So give it a shot and think about using recursion whenever you have a problem that does a little bit and then keeps doing a little bit until it's done. Thanks.